Hello, 143 class. This is a homework example from section 2C. This is problem number 5. And if you get caught up in the little nuances of what's going on in this problem, you can create for yourself an extremely difficult problem, one that you really can't solve with just the methods that you have in front of you right now. So what they're trying to get you to fall into a trap of doing is taking this bird. What it's telling you is this bird can fly 110 kilometers per hour. This little arrow is longer than the other, just meaning the bird can fly faster than this car, can fly faster than this car. So this bird is just like going back and forth, touching these cars, hitting back and forth as those cars are getting closer and closer together. And as the cars make their way towards one another, the bird is just flying between the two. And because it's so much faster than the two cars, it can keep doing that until the two cars crash together. So if you tried to come up with, all right, this bird's going 110 kilometers an hour this way at the moment we start, and it's eventually going to hit this car, it's going to touch this car and be able to turn around, and it says it spends no time turning around, it's instant, and it's still going 110. And if you try to compute, all right, well, how many of these 320 kilometers have taken place when it touches here, when the bird gets over to here? And if you take the time to compute that, and then you're going to turn around and say, all right, now the bird's going to go the other way, and it's going to fly this way until it hits the car again, and you keep doing that, the problem is you come into an infinitely long problem. It's just going to keep having smaller and smaller and smaller units of time that you keep having to add over and over and over again. And in theory, they could, even before the cars crash, you would have these decimal lengths of a second, like tenths and hundredths of a second. So all you have to do in this problem, if you think about it, the bird's just flying back and forth the whole entire time the cars are going towards one another. So all we have to calculate is how long it takes for these two cars to hit. And once the two cars hit, we know an amount of time, and then we can multiply it by the 110 kilometers per hour. We can compute how many hours it's going to take for them to crash into one another, and then we can then compute the distance traveled. All right, so let's do that. All right, the cars are 320 kilometers apart initially. Every hour that goes by, this is 85 kilometers per hour, 75 kilometers per hour. So every hour that goes by, this one and this one are the sum of these two that much closer together. So if we add 75 and 85, that's how many kilometers they get closer together each hour. So they are coming together at a rate of 160 kilometers each hour. Well, we got 320 total. So if we take the 320 and divide by the 160, that's 2 hours. So in 2 hours, these cars are going to crash into one another. Right? So until they collide, that bird's going to keep flying back and forth. So that bird's going to just fly back and forth for 2 hours. And it's going 110 kilometers per hour for these 2 hours. So multiply by 110. And there's your answer, 220. So there's all the work I did on this problem. I just took the 2 units of speed, or the 2 measurements of speed that I was given. I added those 2 numbers together, and that gave me how much, because they're going towards one another, that's how much distance they're taking off the total every hour. So they're taking off 160 kilometers every hour. Well, if they're doing it every hour and we start with this amount, it's only going to do the division, it's only going to take this long, 2 hours, for the 2 cars to collide. And this bird is flying until they collide, so it's flying for 2 hours. So we just multiply it by its rate of speed, and that's how many kilometers it's going to be. So 220 kilometers is our answer here.